Shock dynos come in many forms, and all of them have upsides and downsides. But more than that, each one excels in certain applications, so let's deep dive on each one. The most basic shock dyno on the market has a crank mechanism. We won't dive too much on this kind of shock dyno because it has various limitations. Although it has fewer parts than other shock dynos, it's actually more prone to unwanted sideways movement, making it less accurate. Hence comes the Scotch-Yoke technology. Dynos with this mechanism quickly became the best bang for buck option for any suspension workshop, given their simplicity and reliability. The sturdy structure and very tight tolerances of this mechanism is what ultimately ensures accurate and repeatable test results. These shock dynos are equipped with an electric motor with different power outputs, depending on the kind of shocks you are expecting to test. These motors are directly coupled to the Scotch-Yoke mechanism that converts the rotational movement of the motor to a vertical movement. You are able to test shocks, cartridges or full front fork assemblies up to 3000 mm per second, which covers more than 95% of all relevant applications you might deal with customers on a daily basis. The best thing about Scotch-Yoke dynos is that they provide an amazing platform for the daily work suspension workshops face. Its reliability makes it a powerful tool to test, validate and diagnose the many shocks and forks that undergo a full service or revalve work with accuracy and precision. However, there is one limitation to what the Scotch-Yoke design can deliver. By design, it can only test dampers in a sine waveform, since it travels the same distance up and down. That is not a bad thing in itself, but if you want to squeeze all the performance out of your shock, an electromagnetic linear actuator is the best bet for you. And if you are after the ultimate R&D machine, nothing beats the potential of Laba 7's EMA. If Laba 7's Scotch-Yoke Dyno is a supercar, powerful, precise and do-it-all machine, then EMA is a rocket ship. It's in a completely different league in terms of speed, power, accuracy and possibilities. An EMA is composed of an actuator much like an hydraulic one, but is engaged by an electromagnetic field throughout its entire travel. Considering that an EMA has considerably less moving parts, it becomes even more reliable than any other dyno. But what truly stands out is that it is not bound to any specific motion profile like the Scotch-Yoke or crank. It's possible to define any motion profile to suit any testing scenario imaginable, from 1 mm per second up to a blistering speed of nearly 7000 mm per second. It's even possible to upload a specific track data from a vehicle suspension system and replicate it on any damper. This provides a whole new array of information while testing a newly developed suspension technology, or assuring that the highest racing performance parts will deliver the results needed on a racetrack. Moreover, it makes very little noise. During tests, basically all you hear is the sound of the damper. This is a crucial feature in the development of EV suspensions, for example. Most of the time, there isn't a better or a worse shock dyno, but simply one that suits better the needs in hand. When it comes to Laba 7, Scotch-Yoke and EMA dynos, you can be certain that the Scotch-Yoke dynos will be the hard-working horse of any suspension workshop, making sure that all suspensions and shocks undergo a quality control before being handed out to customers. The EMA, on the other hand, will deliver any testing results you might conceive, whether it's on an R&D department or on a racing team's paddock or HQ. For more information, visit laba7.com and thank you for watching.